All right. All right, so our project will be looking over the different predictors that factor into the success of an NCAA Division I men's basketball team.
For some background information, Division I men's basketball is one of the two most lucrative parts of college athletics between men's basketball and men's football. That's where a lot of schools get their money from, and having a successful team in either of these sports, and specifically men's basketball, has been shown to lead to an increase in applications and therefore an increase in revenue. So in order to explore what makes a successful team, we used data from the 2022-2023 men's basketball season and looked at the impacts from different factors.
Our first hypothesis was that given that the defensive statistics of DRB, EFGD, and FDRD have a significant impact on a team's power rating, or BARTHOG, the response variable, does turnover percentage committed, or steal rate, have a significant impact on the response variable when entering the model last. So, for this hypothesis, we first checked all the given assumptions, BDRB, BEFGD, and BFTRD, separately and together, to confirm that yes, they all did have a significant impact. Then we checked our error assumptions. We see from the plots and from the Shapiro-Wilk test that we do have normal errors, and while the p-value was lower for constant area variance test from the plot and the p-value here, we see that yes, it is constant error variance. From the added variable plots, we see that there's no obvious nonlinear patterns, so the assumption of linearity holds, and for multicollinearity, none of our VIF values were even close to the cutoff of 10, so no multicollinearity issue. For outliers, for the DFFI-TS test, since it was a large data set, our cutoff was lower and we had a lot of potential influential points, as you can see from the tables on the right. For DF betas, we also had a lot of influential points due to, again, the lowered cutoff since it was such a large data set. However, when we look at the Cook's distance values, none of them even came close to the cutoff value of 0.33. However, the influence plot told a different story, with 4 potential values being identified as influential points. So, to remedy this, I attempted both the bi-square and the Huber methods of robust regression, but both of them resulted in a higher amount of influential points and higher standard error than the OLS model. So next, I attempted to bootstrap the OLS model, but again, this resulted in a higher standard error, giving us a less precise model than the one we started with. So the OLS model would be my testing model of choice. We see that our very large F statistic from the ANOVA table of 50.39 is far greater than the 3.87 critical value, and so our p-value was incredibly small, letting us be able to reject the null hypothesis. Turnover rate does have a significant impact, and we see from the estimation of the coefficient that it has a positive impact on a team's power rating. So it is worth going for steals and playing aggressive, even if it leads to the other team having more opportunities for points. To validate this, since our hypothesis was chosen by our model, and so there wasn't really anything to compare it to, but we used the RSME value being pretty low to estimate that we have a good predictive power.
For the second hypothesis, we chose to look at if different shooting rates allowed have different impacts on the team's power rating, and so to do that we looked at the free throw rate allowed, and then the 2-point free throw shooting rate, and then the 3-point shooting rate and their effect on the power rating. And then for the actual diagnostics, there were no sort of violations between normality, error variance, linearity, and multicollinearity. There were some outliers in influential cases, but none of them were extreme based off of any tests, and so I elected to keep those in. And then for the remedial methods and bootstrapping, I used a robust regression, and the robust regression was more narrow for the confidence intervals for several of the betas, but the overall residual standard error for the robust regression was slightly larger than the original least squares residual, and so I chose to just keep the ordinary least squares model for any sort of testing. In order to look at the predictive power, I compared several of the models, and the original model with all 3 predictors had the best predictive power. And so that was just another way to support using that full model. And then using the actual hypothesis test, it was found that we would reject the null hypothesis and that the 3 different shooting rates had different impacts on the power rating. And specifically, exploring which predictor had a different impact led to seeing that free throw rate had a different impact than 2-pointers and 3-pointers, but 2 and 3-pointers had relatively the same impact, which was also seen when looking at the confidence intervals. So if a team wanted to have more success, then they would focus on disrupting 2s and 3-pointers rather than limiting the number of free throws.
For research question 3, the question is, does turnover rate, TOR, and steal rate, TORD, impact a team's power rating, BARTHAG, which is the response variable? And does this impact vary between teams in Power 5 conferences and non-Power 5 conferences? Additionally, are there interaction effects between TOR, TORD, and Power Conf that influence BARTHAG? The null hypothesis basically states that all of them are 0, whereas the alternative hypothesis is that any beta is not 0. We first start off with diagnostics. So we check for the multicollinearity using the VIF test and the normality using the QQ plot. We can see that for multicollinearity, we have a violation as the values are not less than 10, as we have values in the 3000s and hundreds. We see that there is no normality violation from the QQ plot. Going ahead with the added variable plots to check for linearity violations, we see that there are no linearity violations. We look at the outliers and influential cases next. Using the Cook's distance, we can see a couple of strong influential points at 130, 72, and 24. We will also be using DF betas to compare influential cases and outliers. We see that there are a couple of outlier cases using DF betas, and we will now try to apply remedial methods to see if we can address them. To address the multicollinearity issue, we take the following steps. We first transform X and then perform robust regression to deal with the outliers and influential cases. Below is the table attached for the VIF values after transformation. We can see that all the values are less than 10, indicating that multicollinearity has been taken care of. Looking at after performing robust regression, we observe a slightly better DF betas plot, indicating that outliers and influential points have been taken care of, and therefore we can now proceed with this as our full model for our comparison. So we have both the models over here, the complete model, which includes all the betas, and the reduced model, which is only which does not include the interaction terms. We will be interpreting these results based on the t-values. We observe that for the standard residual error, the reduced model has a standard error of 0.2114, whereas the full model is 0.2056, indicating a slightly better fit. While the values are not that significantly different, we must consider all factors in this case because they all add up towards the full model, and therefore the full model is the better fit. So we can conclude that there is a relationship, interaction effect relationship that comes into account when considering the full model. And these affect the teams in Power 5 and non-Power 5 conferences as well.
So for the next question, I decided to look at the two main methods of giving the possession of the ball to the opposing team, turnovers and free throws. And I wanted to know if these had equal impact on the team's power rating based on how the ball is moving. So specifically, I want to know if the free throw rate and the turnover percentage committed had equal impact on the model, as well as if the free throw rate allowed and the turnover percentage allowed had equal impact. And so doing diagnostics on the full set of data, we see that both the Shapiro-Wilk normality test and the Bush-Pagan test return p-values of over 0.05, indicating that there's no issues in normality or constant variance. And the added variable plots seem to indicate linearity as well. And using the VIF function, we find that the return value for all four variables is well below the value of 10, indicating no issues in multicollinearity. So moving forward, in order to try and identify influential points, I utilized Cook's d-test. And so what we found is that some points kind of seem that they may be influential, and some also seem to be outliers in the X variables. However, running more numerical tests, we see that none of the points actually come up as being influential at all. However, there are 2 points, 268 and 284, which are outliers on X. However, seeing that there may be influential points, I decided to run further tests using the DF fits model. And as we can see here, this did return some values of influential points, indicating that there are issues with this and it may be necessary to run robust regression. And so I decided to do so. And as we can see with the summaries of the OLS and robust regression models, the robust regression does have a lower residual standard error, indicating that it's likely a better model. And running DF fits with it as well, we are seeing that there are fewer total influential points, indicating that this should be a better fit. Next, I decided to run bootstrapping to further improve the model, which I ran on the robust regression model. As we can see, the standard errors decrease for all of the betas in response, and below are listed the 95% confidence intervals for each of the impacts. And what we can see is that none of these confidence intervals overlap at all, indicating that it's likely not the case that they have equal impacts. In order to further see if the reduced model might be beneficial, I ran k-fold cross-validation on both the full and the reduced model, and what we can see is that the full model has a lower RMSE value, indicating that it's likely to be a better fit than the reduced model, meaning our null hypothesis is likely to not be true. And to know this for certain, I ran a GLT test, and we can find that when testing the null hypothesis, we get a statistic value of 29.25396, which is significantly greater than the critical value, and so we can reject the null hypothesis and claim that during the 2023 season, free throw rate and turnover rate had unequal impacts on teams' power rating for receiving and/or losing possession.
All right, and finally, for my hypothesis, I'll be looking at, does three-point shooting percentage have an impact on a team's power rating regardless of whether the team belongs to a Power 5 conference? So the important thing to look at here is the Power 5 conferences, which include the ACC, the Big 10, the Big 12, and the SEC, and the Pac-12. These are deemed as the more influential and popular conferences, and then the non-Power 5 conferences are more of the less influential and less popular conferences. So my variables in this case are three-point shooting percentage, the categorical power conference variable, the interaction effect of three-point shooting percentage and power conference variable, and the response variable of the power rating. So my null hypothesis is looking at whether the interaction effect has a significant impact on a team's power rating. So the first thing that I looked at was the issue of multicollinearity due to the fact that there is an interaction effect in the model, and just as I expected, there was an issue of multicollinearity. So to address this issue, I transformed the x variable using the scale function R, and this alleviated the issue of multicollinearity. So the next assumptions that I checked were the constant variance assumption and the normality assumption of the residuals. The normality of the residuals do follow a normal distribution as seen by the Shapiro test and the QQ plot. However, after conducting the Bruges-Pagan test, we see that the constant variance assumption of the residuals is violated. So in order to address this, I performed a Box-Cox transformation and a WLS model, trying to see if this would alleviate the issue of constant variance. However, with the Box-Cox transformed model and the WLS model, they both violated the assumption of constant variance. So the next thing I looked at was a k-fold validation to see which model had the best predictive power. And we see that the original scaled model with the transformed x variables had the lowest RMSE value of 0.1944. So we continue evaluating with the original scaled model. After doing the k-fold validation, I look at outliers and influential cases. And it appears that there are a few influential points within the model. So in order to evaluate this further, I did a robust regression and compared the robust regression model with the original scaled model. And looking at the residual standard error of the original scaled model and the robust regression model, we see that the original scaled model has a slightly less residual standard error than the robust regression model, meaning that we will continue to work with the original scaled model. So after going through all the diagnostics and remedial processes, I performed the bootstrap confidence intervals in the GLT test. The main bootstrapping confidence interval that I'll be looking at is the confidence interval for the interaction term, and we see that it does contain 0. So using this information along with the GLT test, we failed to reject the null hypothesis and determined that there is not enough evidence to conclude that a team's three-point shooting percentage has an impact on their power on a team's power rating, regardless on whether the team is a part of a Power 5 conference.
To sum it all up, From hypothesis 1, we were able to determine that playing aggressively, and therefore increasing TORD, has a very positive effect on a team's Barthog value, even if defensive statistics are considered to be significant already.
From the second hypothesis, we found that not only do free throw rate, 2-point rate, and 3-point rate have different impacts on the power rating, but specifically free throw rate had a different impact than 2-pointers allowed and 3-pointers allowed on the power rating for a team.
From hypothesis 3, we see that steal rate and turnover rate have different impacts on power rating and are different for Power 5 conferences and non-Power 5 conferences.
For hypothesis 4, we found that free throw rates and turnover rates did not have equal impact on a team's power rating when paired by the nature of the possession change.
And finally, for hypothesis 5, we see that 3-point shooting percentage did not have a significant impact on a team's power rating, regardless on whether they were in a Power 5 conference or not, meaning that it is important for teams to look at other factors such as defense and their steal rate.